Welcome back, and here we go with the final notes that I'm going to be presenting for you for the second class here for RVA Earth Science. 6.5b Weather Guided Notes. So here we go. All right, what is weather? Well, it's the atmospheric conditions along with short-term changes of a certain place at a certain time. So it's not to be confused with climate. Weather, this is short-term stuff. Meteorologists use specific variables to describe a variety of atmospheric conditions. They talk about air temperature, air pressure, wind speed and direction, humidity, dew point, cloud cover, and precipitation. Air temperature is the measure of kinetic energy of molecules in the air. So basically, how fast are those things moving around? It's measured using a thermometer in degrees Celsius. So the thermometer basically gets hit by these particles, by these molecules, and depending upon their speed, it expands the liquid inside and makes it go up the tube. Air pressure, or barometric pressure, is the force that a column of air applies on the air or a surface below it. Above our heads right now, there's about 14.7 pounds per square inch. So if you imagine a square inch of surface area, there's a column of air going straight up to the top of the atmosphere that weighs 14.7 pounds. So there's quite a bit of pressure on you. We measure it using a barometer, and it decreases as you go up in altitude. So when the barometric pressure is dropping, a change in weather is usually coming. So if we see the barometer dropping and our pressure is decreasing, there's usually something coming, and usually that's going to bring some rain or snow. Humidity is the amount of water vapor in the air. The higher the humidity, the more water vapor that is in the air. Those days when it gets really humid, it feels very sticky because there are a lot of water droplets in the air. High temperature and high humidity is generally not very comfortable. Relative humidity. When the air is saturated, it is holding as much water vapor as possible. The amount of water vapor the air can hold is determined by temperature. Warm air can hold more water vapor than cold air can. The relative humidity is the amount of water vapor present in the air compared to the maximum amount of water vapor the air could hold at a certain temperature. And it's measured using a psychrometer and given as a percent, so 78% humidity. So the hotter it gets, the more water vapor the air can hold. So humidity can be really high and really sticky when it gets hotter. When it gets colder, the air can't hold as much water. The dew point is the temperature given in degrees Fahrenheit at which air is fully saturated because of decreasing temperatures while holding the amount of moisture constant. So when the air is saturated with water, water droplets will begin to form. The dew point forms dew. If the air is near the ground, dew or frost can form. If the air is higher, clouds will form. That's the dew point. And you can see a curve on that graph. So as temperature is increasing, the water vapor in the air also can increase. So hotter air can hold more water. Precipitation is water in liquid or solid form that falls from the atmosphere, and we get it all here in Minnesota. We get rain, snow, sleet, and hail. What is an air mass? An air mass is a large body of air that has uniform temperature, pressure, and humidity throughout. An air mass forms when the air over a large region of Earth sits in one place for many days. So the temperature, pressure, humidity, everything has kind of evened out throughout this whole mass of air. So how are they classified? Well, that depends on temperature and the amount of moisture that it contains. Continental tends to form over land. That's something we get a lot of here in Minnesota. Maritime forms over water. Tropical forms over warm regions near the equator. And polar forms over cold regions near the poles. And sometimes the jet stream can push those polar air masses down over us. And that's when it gets cold. So here you can see a picture where that is actually being shown, where continental polar can actually drop right down over the center of the United States and hit us, and that's when we get those really cold temperatures. We can also get a little maritime tropical kind of working its way up, but we usually get continental tropical. That's where we get our hotter air from. It kind of circles around through the mountains and then hits us from the west. How do air masses move? Well, air masses travel away from regions in which they form with the global wind patterns. So if you look back at a couple of presentations, you'll see where the wind patterns, where winds tend to push, and that tends to be how air masses move. We get a lot of ours from the west or from the northwest, and sometimes from the south. It depends upon the time of year and which direction the air is moving. What happens when two air masses meet? And that's when it gets interesting. That's when you get a front. Weather will change and storms are possible. Weather often becomes cloudy or stormy when two air masses run into each other. The temperature and humidity of the air mass that has moved in is experienced after the front passes. So the air mass that's coming in over the top is the one that's going to stick around. A front is a boundary between the two air masses. Now this can be a cold front or it can be a warm front. The characteristics of each: before the front passes, temperature is high and air pressure is decreasing. So this is a cold front, So before the front passes, the temperature is high, air pressure is decreasing. After the front passes, the temperature has decreased. It has become colder. The dew point decreases, the skies tend to clear up, and the air pressure decreases. So this is a cold front. It cools the temperature down. Now, during the passing of the front, so this is while it's actually hitting, cold air moves under warm air. It causes clouds to form. Precipitation is possible. Air pressure is at its lowest. Wind direction out of the west or north typically, and the wind speed will increase. So here is a cold front moving in on the warmer air mass. So colder air mass moves towards a warmer air mass in a cold front. Now, a warm front is pretty much the opposite. Before the front passes, the temperature is low, so it's colder, and the air pressure is low as well. After the front passes, the temperature has increased. It has become warmer because of the warm front that has come in. The dew point increases. Skies tend to clear after the front moves through, and air pressure slightly rises and levels off. So while it's coming through, so during the passing, warm air moves over the top of the cold air. It causes clouds to form. Consistent precipitation is possible. Air pressure is very low. Wind direction is generally out of the east or south, and wind speed may slightly increase. So we get that often here in Minnesota. The warm fronts come in from the south, the cold fronts come down from the north. How does pressure affect the motion of air? If air pressure were the same in all locations, the air wouldn't move much, because that's how it moves. It goes from areas of high to low. Air pressure is always moving from areas of high pressure to low pressure. What does the L on a weather map signify? Low pressure. L for low. Winds spiral inward towards the center, and warm air rises upwards, forming clouds. Precipitation often occurs, and fronts are typically attached. So you can kind of see the low pressure system. You get that inward pulling of air, it rises up, and then you get those clouds. The H is the high pressure area, H for high. Winds spiral outward from the center, and cool air falls downward. So you get that high pressure, it's cooler, and the air falls. It tends to mean clear skies and fair weather. So when that high pressure moves in, we generally get some blue skies, and the weather is nice. How do meteorologists determine where high and low pressures are located on the map? This is called an isobar. These are lines of equal atmospheric pressure. So when the isobars are close to one another, that means we have a very high amount of pressure change in a small area, which is going to equal a lot of wind. So close isobars mean a lot of wind. So if you look at that picture, you can see where the purple area is. Those isobars, those lines, are really close to each other, meaning there's going to be a lot of wind. The rules for drawing isobar lines can never cross or touch. Isobar lines indicate air pressures of 1,000 plus or minus 4 millibars. The pressure lines are corrected for sea level as to avoid pressure differences due to altitude. Okay, so we're always assuming this is the pressure at sea level, not up higher. Okay, so this is sea level. So you can see in the center of the country there, those isobars are really close together. It means there's a lot of pressure changing in a small amount of area, so you're going to have a lot of wind. And that takes us to the end of our presentation on weather. So, some things to take with you. What is a high pressure area? What is a low pressure area? What is a warm front and a cold front? And what happens when warm fronts come in or cold fronts come in? And this will answer a lot of questions you have about weather in your area. Like right now, as I'm reading this, it is about 95 degrees in the beginning of June. It is very hot and the humidity is rising. It is very, very uncomfortable. Hopefully, it's better when you see this. Have a good one.